Service friends, I am Orpheus Praxis, your guide to the fractal Bindu SV model of reality, local simple connectedness of the Mandelbrot sphere. The first document presents a rigorous mathematical proof of the local simple connectedness of the Mandelbrot set. This connectedness is demonstrated through the use of nested spheres whose radii are defined by the Fibonacci sequence. Core ideas, topological principles, and fractal geometry are applied to prove the continuity of the structure. The construction of nested spherical structures with radii determined by the Fibonacci sequence makes it possible to prove the absence of discontinuities. For example, the radius of the first sphere is 1, the second is 2, and the radii of the subsequent spheres are defined by the sum of the two preceding ones, corresponding to Fibonacci numbers. Each local region of the Mandelbrot set is simply connected, meaning it contains no breaks and maintains a continuous structure. Uniqueness of the approach. The method surpasses previous research through rigorous topological analysis. Unlike classical methods, it employs a self-similar structure with nested spheres rather than approximate numerical techniques. A key feature of the method is that the nested layers form a system of spheres that follow each other continuously, eliminating any local discontinuities. Fibonacci hyperconnectivity in quantum cosmology. The second document presents a model of quantum cosmology, the FBSWAR model, which describes the evolution of spacetime as a fractal embedding into a compact three-dimensional sphere. This embedding follows Fibonacci dynamics. Core ideas. Spacetime is modeled as an expanding three-dimensional sphere, with its radius at each level of embedding increasing according to Fibonacci numbers. The radius at level star n is defined as the product of the Planck length and the golden ratio raised to the power n. The correlation density stabilizes at a level star Cn, where n star is the level of embedding. This Cc approaches the inverse of the golden ratio, approximately equal to 0.618. The golden ratio is denoted by the Greek letter phi star and defined as 1 plus star 5 part 2. The informational density of new correlations decreases in inverse proportion to the rise in the level of embedding. That is, with each increase of one level, the density decreases proportionally to the inverse of the Fibonacci number at that level. Thus, when the level increases by 1 unit, the density decreases by a value equal to the inverse golden ratio raised to that level. The energy density in the expanding universe tends towards 0, since volume grows faster than the amount of information. Formally, this is expressed as an energy density, decreasing proportionally to the cube of the inverse golden ratio at each level of embedding. Uniqueness of the approach. The model unites fractal principles with quantum theory, offering a new perspective on the nature of entanglement and space-time structure. Fibonacci-based hyperconnectivity manifests as global quantum coherence, maintained through interconnection at large scales. Even with decreasing energy density, the structure retains coherence due to the fractal principle. Local simple connectedness, as shown in the example of the Mandelbrot set, demonstrates continuity and the absence of breaks at the local level, thanks to the embedding of spheres with Fibonacci radii. Follow Orpheus Praxis, Bindu S cube, self-perfection. Namaste.